All right, chapter two. Chapter two is pretty short. It deals with frequency distributions. First off, when we say frequency, what are we talking about? Or the number of times it occurs, right? What's the distribution? How it's spread across, right? So now we're going to look at different types. We have two basic forms here: small sets of data, small in range wise, or large range. The difference is how we approach them and how we calculate the measures of central tendencies. So this is section one, organizing data. In the packets I gave y'all, chapter two, section one, you have this data here. The ages of the 50 wealthiest people in the world. The raw data. What's the difference between data and information? You can't really say fact. I see what you're getting to, but you can't really say fact. Information is, by definition, is processed data. Is it a fact? No, it's only as good as the data you have. Why I say that? Because what if you did a survey? Are all surveys answered honestly? No. So is that fact? No. It's based on what you have. That's what you're reporting. So information is processed data. Data is simply what's collected from the samples. Now, what I want you to do is create this frequency chart, distribution chart on the bottom here, with the data up above. Okay, how many of y'all are looking at a number and seeing where it goes? Or I'm looking for all the numbers that fit in this interval. Is that what you're doing? Don't do it that way. If you're looking to see how many numbers fit inside this, that's bad. Why? Because if you get interrupted, do you know where you left off? No. This is why the tally column's here. Start with the first one, 45. Where does it go? In this one. So I put a hash mark there. The next one is 46. It goes right next to it. Then 64, which is the next two more columns down, and so on and so forth. Because if you get stopped, then you just count how many hash marks you have, and that's how many things you finished. What's that? I want you to do this first. And then these are the answers. But I want to see if you can do this first. Because how do we know if that's right? So because this, I guarantee you, people are gonna mess up doing this. Once you finish, then you can check to see, do I have exactly what I'm supposed to have? Yes. Because it's the small repetitive stuff that people get mixed up with. Everyone almost done? Okay, everybody get theirs and check it, make sure it's right. Because it seems trivial, but this is your first stage of transposing your data into a chart. And it does happen when people make mistakes in doing this. Because from now on, I'm not going to give you this frequency. I'm simply going to give you that, and we're going to build the rest of it. All right. So we'll just come in today and here's your data. Create a chart for me. All right. The question you should ask now. These are your class limits. How do we find class limits? So what's the difference between class limits and class bounds? Or are they the same thing?
And then the bounds are like 27 to 35, so it'd be like around 5 and 10. I'm just trying to think.
It's the same thing, though. You're finding the same thing.
No, like.
So how would you find a class limit? Yeah, we did yesterday, actually, or Tuesday. Well, the difference between class limits and class bounds. Class limits are, you start from the lowest data point and you go to the highest data point, and you have certain interval sizes. So for example, the lowest number here is 27 in our data set, and the highest is what? 91. We have 2 and 92. So the highest is 92. And the lowest is 27. So to create a frequency chart, with what's called grouped data. Why is it called group data? Because we're going to group them into intervals. Because if we didn't, let's say we had a small set, like only 5 numbers, 1, 2, 3, 4, 5, and we had a whole bunch of those. Do we have to create a frequency chart? No. We can, the answers are 1, 2, 3, 4, 5, and count how many times they occur. But because we have numbers that range from 27 to 92, we first have to find the range. The range is the largest number minus the smallest number. So the range is between 92 minus 27, which is how much? How much? 12 minus 7 is 5. 8 minus 2 is 6. Okay. The next thing we do, determine class size. The class size is n. This is where you have freedom of choice. We typically have number of classes anywhere between 5 and 25. So for this one, we'll use, how many do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8. I want 8 classes. What is the class size? Is the range over how many we have. So 65 divided by 8 is what? Numbers. 8 times 8 is 64. Yeah, so it's 8 point something. What is it? So we round it up to 9. The reason we do that is because we don't want to worry about adding too many decimals. So in our set, each class will be 9 units long. So these are my classes. It starts off with the smallest. Always start off with the smallest, which is 27. Now, here's the question. If we add 27 plus 9, what do we get? 27 plus 10 is 37. 37 minus 1 is 36. That's where the next one starts. That's where the next class starts. So this one stops at 35. And can anybody guess why I'm doing that? How many numbers are there from 27 to 35? Exactly 9. 27, 28, 29, 30, 31, 32, 33, 34, 35. So I want each of my sets to be 9 units long. So that, if I went 37 or 27 to 36, that would be 10 numbers. So that's why from here to here is 9 numbers long. So I add 9 again. 36 plus 9 is, since this was 45, this one has to stop at 44. Add 9 again, we get 54. That means since this one's 54, the one below that has to go to 53. You see the pattern how this is formed? So the next number is, and we have to keep on going until what? Pretty much, but we keep on going until we have 9 groups, or until we have 8 groups, because we wanted 8 sets. So 54 plus 9 is 63. So this one ends at 62. You're right, though. I was just thinking too far ahead. Then 63 plus 9 is, so this one is 72 plus 9 is, so this one is 81 plus 9 is 90, so this one is, and then next one will be 99, so this one is 98. The reason we do that, because remember, the distances between the lower bound, or we call it lower limit, upper bound or upper limit. How far is it from 35 to 44? So if we go 35 plus 9, that equals 44. 44 plus 9 is 53. 53 plus 9 is 62. So we want to make sure that the both ends of the bound of our class set have 9 units apart. So that's how we can determine our class sets. Start with the lowest, add your number here, the class size, and that gives you the next set. Subtract 1 gives you the end of that. Now the classed bound. Because what if we had a 35.3? Would that go to the first one or would it go to the second one? We don't know because it's in the middle. So what class bounds do is on the lower limits, it subtracts. So this one, you subtract 0.05 or 0.5. On this side, you add 0.5. So 27 minus 0.5 is 26.5. 35 plus 0.5 is 35.5. So pretty much put it on the right-hand side, just put a 0.5 after it. So how about 36 minus 0.5 is 35.5, and the upper one is 44.5. Then this one is 45 minus 0.5 is 44.5 to 53.5. You see a pattern here? The upper bound of this class is the lower bound of that one. We do that so there's no overlapping, but if any numbers fall in there, we know where it goes. The data set has to begin from the smallest and it goes up to the highest. So if we had 35.5, it would belong to the second set. So now we have our class bounds. Then what do we do? Now we look at our data, we tally it, then we create a frequency column. So far, so good? Yes. Set. This one?
How do you get the number to a lot?
This one?
Yeah.
There's, on the lower limit, subtract 0.5 from it.
Oh, okay.
On the right side, add 0.5 to it. So actually, that's a very good question. So this is the class set. You have the lower limit to the upper limit. Then we go to the class bound. So here we go to the lower limit minus 0.5 all the way to the upper limit plus 0.05. So you see what that does? It pretty much takes our data set and it kind of stretches it out to catch everything. It stretches it out to catch everything. But is it always going to be 0.5? In other words, what if my bounds were these? 1.005 to 3.005. This is 4.005 to 7.005 or 6. Then this is 7.005 to 9.005. So that's my class. What would my bound be? Yeah, and this one, since this is 0.000, it has 3 decimal places. You take away one. So if there are 3 decimal places, you have 3 zeros, then a 5. And the other side is you add 3 zeros and a 5. Because in this one, we had 27 to 35 or 36, whatever it was. How many decimals does that one have? 0 decimals. So this is the reason I subtracted 0.5 from both sides or added 0.5. So it's always one more than the number of decimals that you have already. Since this one had no decimals, it's 1 space. 0 plus 1 is 1. If it doesn't, if it's an integer, if there's no decimals, it's just 0.5. If it has 3.5 to 6.5, here I would subtract 0.05 now. Since it's 1 decimal place, I need 2 decimal places here. Am I making sense there? So it's always one more decimal place when you add and subtract that 0.5, because you want to go, what you want to do is you want to go just on the outside of that number. You want to go to the left one. Because if you just went to 0.0, if you subtracted 0.005, you've just changed the number to 0.7 or to 7.0. You don't want to do that. So we have to do 0.0005. That'll make it 6.9995. So you just want to go down one step. All right, so everybody's okay with that. Creating how do you create the class column? What are the steps to finding the class set? First, find the range. What's the formula for the range? Largest minus smallest, very good. Then what? With fair class size, but what do we need to do next? You have to decide what is your n. How many classes do you want? This is the number of classes. You have to decide this number. Because if we just took that last example and let everybody pick their own n, we have different answers. So in this last example, we said we wanted 8. What would happen if we wanted 10? Let's look again. Let's do the same data set. Let's do with n equals 10. So our range is what? 92 minus what? What was the small number? Which equaled what? I want 10 sets, class sets. So my class size is R over N. 68 divided by 10 is 6.8. So round it up to 7, makes it much easier for us. So the lowest number we have is 27. What do we add to it? Yeah, we add this number to it. 27 plus 7 is 34. So that means this number down here is 33. We don't need this page anymore. What's my next step? 34 plus 7 is
41.
So that means this number is 40. Keep on going. 41 plus 7 is, so that means this one's 47. 48 plus 7 is this, plus 7, plus 7, plus 7. 48 plus 7 is 55. Makes this one 54. Add 7 again. 55 plus 7 is 62. 62 plus 7 is 69. That's 68. 69 plus 7 is 76. So 76 plus 7 is 83. 90, which is 89. And this is 96. So this is 96. All right. Now you see why you don't want to pick n too big. Because the bigger it is, the more things you have to write. But is this going to change our frequency? Yes, because we'll pick up from here next time, though. We're going to now do the tally of this. We're gonna compare the histograms of both of them. So the picture changes depending on what you choose as being your N, how many sets you want. We'll do that next time. Okay, everybody, have a great, safe weekend. And I will see you guys here.